Somewhere past Neptune, on a frozen world barely a third the size of our moon, something is missing. Not an object, not a landform, a signal. A very specific wavelength of light that should be there according to every model astronomers have ever built, and isn't. For years, nobody noticed. Then the James Webb Space Telescope looked closer than any instrument in history has ever looked at Pluto. And it found a gap in the light itself, a shadow where no shadow should exist. Scientists don't have a name for what's causing it. They don't have a match for it anywhere else in the solar system, or in any exoplanet ever studied. And the strangest part isn't that it's on Pluto. It's that the exact same gap, the exact same fingerprint, is sitting on a moon of Saturn nearly 1 billion miles away. Two worlds that share almost nothing in common are somehow hiding the same secret. And that is where this story actually begins. For decades, Pluto sat at the edge of public imagination as a kind of afterthought. Demoted from planet to dwarf planet in 2006, it became the punchline of astronomy classrooms, the not a planet anymore trivia answer. But out past Neptune, in the frozen dark of the Kuiper Belt, Pluto never stopped being strange. In July 2015, NASA's New Horizons spacecraft screamed past it at over 30,000 miles an hour, close enough to catch a glimpse humanity had waited 70 years for. What it sent back broke every assumption scientists had walked in with. Instead of a dead, cratered ball of ice, New Horizons revealed mountains of frozen water taller than the Rockies. A heart-shaped plain of nitrogen ice big enough to swallow Texas. And something nobody had predicted at all, a layered blue haze wrapping the entire planet, rising more than 300 kilometers into the black sky above it. That haze shouldn't have existed, not at that altitude, not with that structure, not on a world this cold and this small. And for almost a decade, it sat there in the data, a mystery nobody had the tools to solve. Then Webb turned its mirror toward Pluto, and that's when things stopped being merely strange and started becoming something else entirely. Here's what most people don't understand about how a telescope like Webb actually works. It isn't just taking prettier pictures, it's reading light like a signature. Every molecule in the universe absorbs a very specific, very particular wavelength of light, its own unique barcode. When astronomers point an infrared instrument at a distant world and break its light apart into a spectrum, they're not looking at colors. They're looking for the missing pieces, the dark lines, the wavelengths that got swallowed on the way to the telescope, because something down there ate them. Oxygen has a barcode, methane has a barcode, carbon dioxide has a barcode, and in mid-2026, a team of researchers scanning Webb's most recent data on Pluto found a barcode that matched nothing. Not in any catalog, not in any laboratory reference, not in any published study of any planet, moon, comet, or exoplanet ever observed. A wavelength near 511 micrometers, sitting right there in the spectrum, absorbing light in a way that has never been recorded anywhere else in the known universe. Read that again. Never recorded anywhere else. And here's where it gets worse. When the same team checked Titan, Saturn's giant moon, a world with rivers, lakes, and rain, just not made of water, they found the identical signature, the exact same missing wavelength. On a world that has almost nothing in common with Pluto, Titan is roughly twice Pluto's size. Titan has a thick, hazy nitrogen atmosphere thick enough to fly through. Pluto's atmosphere is so thin it barely qualifies as an atmosphere at all, and it's 4 times farther from the sun, colder than anywhere else humans have ever measured light bouncing off solid ground. And these two worlds are separated by nearly 1 billion miles of empty space, formed in different eras, orbiting different planets, built from different ratios of ice and rock. And yet something, some molecule, some unknown chemical structure, is present in significant quantities on both of them, and on neither of them has it ever been identified. Think about what that means. This isn't a case of scientists finding a known chemical in an unexpected place. This is scientists finding a completely unknown chemical fingerprint, one that doesn't correspond to any known molecule in any chemistry database on Earth, showing up on two worlds that shouldn't logically share anything. The researchers who found it didn't publish with confident answers. They published with a confession. They went through every reference paper on planetary spectra they could find, and in their own words, could not locate a single band in the literature that matched what they were seeing. That is not the language of scientists who solved a mystery. That is the language of scientists who just discovered they don't fully understand what they're looking at. So, what could it be? The leading theory circulating through planetary science circles right now points toward something called benzene, a ring-shaped hydrocarbon, possibly mixed with something else entirely unidentified, or some exotic form of acetylene or ketene ice, compounds normally associated with extreme high-energy chemical environments. But here's the catch, and it's the kind of catch that keeps researchers up at night. None of those candidates cleanly explain the strength and shape of the signal. On Pluto, the absorption line is roughly 3 times thicker than it is on Titan, meaning whatever this substance is, it's far more abundant on Pluto's tiny, frozen, sunlight-starved surface than on Titan's thick, churning, chemically active one. That's backwards from what anyone would expect. Titan has the atmosphere, the energy, the chemical factory conditions to build complex molecules. Pluto has almost nothing, barely enough atmospheric pressure to register, temperatures hovering near 230 degrees Celsius, sunlight so faint that at Pluto's distance, the sun looks like just another bright star in a black sky. And yet Pluto is holding more of this unidentified substance than Titan is. The world with the least energy, the least heat, the least obvious chemistry, has more of the mystery molecule than the world built for chemical complexity. And there's a second layer buried inside this discovery that almost nobody outside the research community has noticed yet. On Titan, the unknown substance isn't spread evenly. It's concentrated more heavily on one hemisphere than the other, specifically on the trailing side, the face of Titan that points backward relative to its orbital direction around Saturn. That kind of asymmetry usually means something is actively being deposited or created by a directional process. Solar-wind interaction, magnetospheric particle bombardment, something with a preferred direction, not simple, even chemistry sitting quietly on the surface. In other words, whatever this is, something is actively producing it, or actively delivering it, in a way that isn't random. This is not a molecule that just happens to be there. Something put it there, unevenly, on purpose, by physical law. But here's where the story escalates into territory that goes far beyond a strange spectral line. Because Pluto has been keeping other secrets, and Webb has been slowly, methodically, pulling on every thread. Go back to that haze. The one New Horizons photographed in 2015, the blue multi-layered atmospheric shroud nobody predicted. For years, planetary scientists had a hypothesis, first proposed back in 2017, that this haze wasn't just a beautiful accident of Pluto's thin atmosphere. They believed it was the engine driving Pluto's entire climate system. A haze made of complex organic molecules, cooked out of sunlight reacting with methane and nitrogen, absorbing solar energy during Pluto's long day, and radiating it back into space as infrared heat during its long, brutal night. If true, it would mean Pluto runs on a completely different kind of climate than anything else in the solar system, not driven primarily by its thin gas atmosphere, the way climate works on Earth or Mars, but by a suspended layer of organic haze particles acting like a planetary thermostat. The problem in 2017 was simple. Nobody had the instrument sensitive enough to prove it. The prediction sat there, untested, for 5 years. Then Webb arrived, and for the first time, its infrared instruments were powerful enough to do something no telescope before it could do, cleanly separate the thermal signal of Pluto from the thermal signal of its enormous companion moon, Charon, which orbits so close and so tightly bound to Pluto that the two bodies' heat signatures had always bled into each other in prior observations. Before Webb, scientists literally could not tell how much of the infrared glow they were seeing came from Pluto and how much came from Charon. It was like trying to hear one voice in a room where two people are speaking in perfect unison. Webb finally split them apart. And when researchers isolated Pluto's true infrared glow, it matched the 2017 haze prediction almost exactly. One of the lead scientists on the project, reflecting on how rarely a 5-year-old hypothesis gets confirmed this cleanly, said it plainly. In planetary science, that kind of quick, direct confirmation almost never happens. This is not chaos. This is strategy, written in the physics of a haze layer that formed itself into a working climate machine on a world with barely any atmosphere at all. And this is where everything changes, because the implications reach far beyond Pluto's own borders. If a thin, cold, distant world with almost no gas atmosphere can build and sustain a functioning, self-regulating climate purely through organic haze physics, that reframes the entire question of what makes a world alive in a planetary sense. Scientists studying Pluto's haze are now looking at it as a possible mirror for early Earth, a version of our own planet from billions of years ago, before oxygen filled the sky, when Earth may have been wrapped in its own haze of organic particles, a blanket of hydrocarbon smog that could have stabilized surface temperatures and helped create the conditions that eventually allowed life to take hold. Pluto, the demoted, dead dwarf planet, might be quietly holding a working model of the exact atmospheric chemistry that helped build the conditions for life on Earth. What most people are not seeing is that the joke planet at the edge of the solar system has become one of the most important natural laboratories for understanding our own deep past. But Webb wasn't done, because while one team was untangling the haze and another was chasing the unidentified 5.11 micrometer signature, a third line of investigation was quietly rewriting the story of Pluto's largest moon. Charon isn't just an ordinary satellite. At roughly 1,200 kilometers across, it's so large relative to Pluto, more than half its diameter, that the two don't really orbit each other in the conventional sense. They orbit a shared point in empty space between them, technically making Pluto-Charon closer to a binary system than a planet and moon pair. New Horizons photographed Charon's surface in detail back in 2015, A world scarred with craters, streaked with bright ejecta blankets, rich in water ice and ammonia compounds. Evidence of impacts violent enough to punch through the surface and expose what lies beneath. But New Horizons instruments, sophisticated as they were for their time, missed something. When Webb pointed its infrared eye at Charon nearly a decade later, it detected carbon dioxide on the surface, a compound New Horizons never picked up at all. And according to informed researchers close to the analysis, that absence had been troubling scientists for years, because carbon dioxide should have been there. It's expected in the materials that formed the entire Pluto-Charon system in the first place, present in the protoplanetary disk from which both bodies were built. Its apparent invisibility to New Horizons wasn't proof it wasn't there. It was proof that the earlier mission simply didn't have the resolution to see it. Webb didn't just find something new. Webb corrected nearly a decade of incomplete understanding about a moon we thought we already knew. And alongside the carbon dioxide, Webb found something even stranger sitting on Charon's surface: hydrogen peroxide. That's not a compound you casually expect to survive, unaltered, on the frozen crust of a moon 4 billion miles from the sun. Its presence tells researchers a story about radiation processing, about how solar and cosmic radiation, over billions of years, is chemically transforming the ice on Charon's surface into new, reactive compounds. The leading interpretation right now is that the carbon dioxide layer detected by Webb likely originates from beneath Charon's crust, dragged up to the surface through impact cratering, meaning every time an asteroid or comet fragment slams into Charon, it's punching a hole straight down into the moon's interior chemistry and spraying it across the surface for instruments like Webb to finally read. Charon isn't a dead rock. It's a slowly excavated archive, and Webb just found the first pages nobody had been able to read before. Now step back and look at what's actually happening here, because this is the part that should genuinely unsettle you. In the space of roughly 18 months, Webb has independently uncovered 3 separate, unrelated mysteries in the Pluto system: an unidentified molecule shared with a moon of Saturn nearly 1 billion miles away, a haze-driven climate engine unlike anything else documented in the solar system, and a chemical archive on Charon that rewrites what New Horizons thought it had already fully mapped. 3 discoveries, 3 teams, 3 papers, and they all point toward the same uncomfortable conclusion: we did not understand Pluto. Not really. Not even after New Horizons gave humanity its first, only, and closest look. The 2015 flyby gave us the geography. Webb, sitting 1 million miles from Earth at the L2 Lagrange point, staring outward with instruments New Horizons never carried, is now giving us the chemistry. And the chemistry doesn't match the story we thought we already knew. According to researchers directly involved in these findings, this is only the beginning. The 5.11 micrometer signal hasn't even made it through peer review yet. It exists right now as a preprint, an early unconfirmed release, meaning the scientific community hasn't finished stress testing it. That should make you pause, not dismiss it. Preprints get published because researchers believe the signal is strong enough, and strange enough, that the wider scientific world needs to see it immediately rather than wait a year for the traditional review cycle to grind through. When scientists route around their own normal process to get a finding in front of other experts faster, it usually means one of 2 things. Either they're confident they've found something genuinely new, or they're hoping someone else can explain it before they commit their reputation to a conclusion. In this case, it looks like both. And here's the detail that should really stop you. Nobody currently has an explanation for why this same unidentified molecule would appear on 2 chemically and physically unrelated worlds. Not sunlight exposure, not proximity to a shared parent body. Pluto and Titan don't even orbit the same planet, not comparable temperature ranges. Pluto is dramatically colder, not comparable atmospheric density. Titan's atmosphere is roughly 1.5 times thicker than Earth's, while Pluto's is barely there at all. The 2 leading candidate molecules, benzene-based compounds and keton-acetylene ices, are associated with completely different formation pathways, which means either both worlds independently manufacture the same unknown chemical through 2 entirely different processes, an enormous, almost improbable coincidence, or there's a shared mechanism operating across the outer solar system that scientists haven't identified yet, something delivering or generating this molecule on multiple worlds simultaneously, a mechanism nobody currently has a model for. What most people are not seeing, buried underneath the headlines about James Webb finds mystery molecule, is that this single detection quietly reopens one of the oldest debates in planetary science. How much of the outer solar system's chemistry is locally generated, world by world in isolation, and how much of it is shared, transported, seeded across enormous distances by processes we still don't fully understand. If this molecule turns out to be delivered rather than locally produced, that has implications stretching far beyond Pluto and Titan. It would mean the outer solar system is more chemically interconnected than current models assume. That material, or the conditions to build specific complex molecules, can move and replicate itself across distances of hundreds of millions of miles, on wildly different types of worlds, under wildly different physical conditions. And once you accept that outer solar system chemistry might function that way, you have to start asking the same question about every other icy body out there. Comets, other moons, other dwarf planets scattered through the Kuiper belt that Webb hasn't even looked at yet. This is where the story stops being about Pluto specifically, and starts being about what Pluto represents. For 70 years, it was a name on a chart, then a controversy over its planetary status, then briefly a photograph from a single flyby in 2015. Now, in less than 2 years of dedicated Webb observation time, it has become a live case study, forcing planetary scientists to rewrite assumptions about atmospheric chemistry, cross-world molecular transport, and the very origins of the organic haze layers that may have once made early Earth habitable. The real story is that Pluto was never actually explored. It was glimpsed once at 30,000 miles an hour by a spacecraft that had one shot and took it. Everything since has been the slow, patient work of trying to understand what that single glimpse actually meant. And Webb, sitting quietly in deep space, still reading light nobody else on Earth can decode, keeps finding new reasons to believe we barely scratched the surface. So where does this leave us? A molecule with no name and no known chemical match, sitting on two unrelated worlds nearly 1 billion miles apart, in quantities that defy the physical logic of where it should be more abundant. A climate system running on haze physics that nobody predicted could function this way, possibly holding clues to how life-friendly conditions first stabilized on early Earth. A moon that New Horizons photographed in exquisite detail and still managed to leave chemically unread, its surface hiding compounds that only became visible once an infrared instrument powerful enough finally turned its full attention that direction. None of these findings are closed. None of them are resolved. The molecule doesn't have an identity yet. The transport mechanism, if there is one, hasn't been proven. The full extent of what's buried beneath Charon's cratered surface is still unknown. Webb is still watching, still gathering more data, still queued up for follow-up observations that researchers are already requesting, hoping to catch a clearer signal, a stronger absorption line, a definitive match. What happens when they get it? What happens if the molecule really is being delivered across the outer solar system rather than made independently on each world? What happens if Pluto's haze-driven climate turns out to be more common among icy worlds than anyone currently believes, meaning it could be operating right now on dozens of undiscovered bodies drifting through the Kuiper belt in total darkness? Nobody has those answers yet. For now, all we know is this. The coldest, quietest, most overlooked world in our solar system just handed astronomers a mystery they cannot explain. A signature that shouldn't exist, sitting in the light of a planet that was demoted, dismissed, and almost forgotten. And it turns out Pluto was never finished revealing what it's been hiding all along.